So we are prepping for our greatest common factor and start a factoring quiz tomorrow. First thing we are going to do, head down to the bottom of the front page. Numbers 15 through 20 on the front of this. We have not done this yet. Give that the big ol' X. So 15 through 20 on the front. On the front of your quiz preview. So we'll get that done and taken care of. So 15 or 20 or goodbye, see you later. We'll deal with those a little bit different of a time. And for right now, what we're going to do is we're going to just go back through. I'm going to use this sort of as a sorts of going back through the lessons for the past few days. So here we go. So looking for the greatest common factor, reminders. I'm looking for the largest number that divides into all terms. That'll be my coefficient. And then I look for the smallest exponent as long as it is in all of my terms. In other words, like if I see X or A or something, if I have A's in all my terms, I look for the smallest exponent, I use that. If it's not there, I don't.
Does the largest number divide to all?
Into all my terms.
All right.
So some of you had already mentioned that you're like, number one, I think it's 6. Right. Because again, if you've got your chart, and I've got some extras if you need it, I'm trying to find one of my rows that has all 3 of these numbers in. If I'm not sure, and I can use the calculator to do the same thing. So I look and I'm like, there's 12 and 18. Oh, there's 36. Okay. Now, notice and be careful, I also see 12, 18, and 36 up in 3. But remember, I want the largest number that goes in. So I always want to make sure when I think I have the biggest one that I keep going. So 6 is going to be my biggest one here. So I pull out a 6. Do I have X's in all of my terms? Yeah, and they all have squares. So X squared will be part of my greatest common factor. Okay, the smallest exponent, as long as it is in all terms. So like for instance here I have X in all of my terms, so I use the X squared because that's my smallest exponent. Do I have Y in all of my terms? No, it's only in these last 2, but I don't have any Y's here. So Y can't be part of my greatest common factor. I'm done.
How did you get 6 in?
Okay, the 6 is the largest number that divides in, let me move this up a little bit. Either I can use the calculator and start dividing numbers in.
The ones that are all, okay.
Yeah, or I'm looking for the number here where I can find all 3 of them. That'll tell me on the outside of my chart there otherwise. But yes, the largest number that divides into all 3.
That's all you do?
And that's it as far as the numbers go. So like on 2, what's the largest number that divides into both 25 and 35? 5 does. And again, the chart would help you with that too if you weren't sure. But now as far as my variables go, yep, we have A's in both. And I have B's in both, but remember, it's the smallest exponent. So with B, I could put B or B to the first. Either one's fine. Do I put C down? No, because I have C here, I don't have a C here. It's got to be in all of them for me to include it. So again, going pretty decent. Now this next one, let's see how close of attention we're paying here. Close. When I'm looking at my numbers and I'm looking for 24 and 60, you may notice at first, you're like, okay, 6. There's 24 and 60, okay? But if I go a little further down my chart, okay, I come down here, ooh, 12's got both of them. So this time, and again, that's one of those, if you put 6, these will probably be 2-point questions tomorrow. I'd probably take like 1/2 of 2, which is not very much. If you put 6, you'd still show me you understood the concept, which is not quite the biggest one. What about my variable terms? Okay, a, because that's my smallest exponent, both of them have an a. I have b to the third and b to the first, and again, I'm always taking the smaller one, so I've got b to the first, but when I get to c's, I have 5 or 2, and again, take the smaller one. So sometimes your greatest common factors can get pretty big. It absolutely can occur, but we just kind of work with that. But take your time on this, and hopefully tomorrow you've got something jotted down somewhere where you can have these 2 bits of info to kind of give you a reminder if you need it. Let's see here. Number 4. Now you're like, well, now what number's in front of this one? I don't see one. Is there a number here? Is it okay? It's 1. Well, the biggest number that can go into 1 and 10 is 1. So that's all I can take. What about my variables this time? Okay. So m, I've got a 1 here, so I'd have m to the first. With my n's, I see n squared and n squared, so n squared is my smallest. And with p's, I see p to the third and p squared smaller, so I use that. But both terms had all 3 of my variables, so I'm good there. Number 5. Coefficients, 9 and 20. What divides into 9 and 20? Does anything divide into 9 and 20?
1.
Just 1. I can look all over my chart and I'm not going to find any row or column that has a 9 and a 20 in it. So sometimes we just got to take the 1. That happens. So then we go into variable mode again and check it out. They both have A's, they both have B's, they both have C's, so I know I'm going to have all 3 variables. What are my exponents going to be on each one? Yep, A or A to the first, B to the second, exactly, because 2 is smaller than 6, and C to the fifth because, again, 5 is the smallest one, 5 is smaller than 9. And I'm set there. Good, good, good. Number 6, the chart should help if you're not sure. 11. I can find 22, 55, and 77 all in my row 11. So I got 11. Do all my terms have X's? Nope, just the first 2, so we can't use X. Do they all have Y? Nope, just these 2. If this one doesn't, messes it up for everybody, so no Y's. Z? Yep. I have a 2, a 3, and a 7. I use the smallest one. Boom. So if you just keep those 2 rules in general, biggest number that divides in, and again, I could play with the calculator on this if I really wanted to, and just try some different numbers until I found one that worked. That's perfectly acceptable. So now, the next part, we increase it. We still are going to do this part, but then we're also going to put the parentheses next to it. So, what's my greatest common factor in number 7? Right, 6 goes into 6 and 18. And again, whether you're using the... Exactly. Once I find that biggest one, because both of these don't have D, so I can't take that out, I put in my parentheses. And basically, we're doing the distributive property backwards at this point. So 6 times what gets me 6D squared? We already had the 6. So I just need the D squared. And then 6 times what gets me to 18? 3. Now again, if that's not one of your strengths, you're like, yeah, I'm not sure. You can either do 18 divided by 6 in your calculator. That'll pop the 3 at you. Or here's another way you can use the chart if you needed to. Because I know it's going to be in the 6. So if I go in the 6th row and I find 18, work your way up to the top. That's how many times 6 goes into 18. So I can even use the chart to find these values inside the parentheses. So it's got some multiple uses for us. 8, biggest number that goes into 8 and 12, 4. My pen's starting to die here. Okay, so do I have r's in both terms? Yup. And again, I use the smallest exponent there. And I have t's in both. And again, I see one that just has a 1, so I'll use that. And again, if you don't put the 1s on your exponents, that's okay. But for some of you, I think it's just good because it makes it more visual for you. All right, backwards distributive. Here we come. 4 times what is going to get me to 12? Okay, 3. And with my variables now, I'm not multiplying anymore, I'm just adding. So 1 plus what gets me to 3? 2. And 1 plus nothing gets me to 1. So I already have my t's. I don't need a t. And then here, I got a minus.
Why'd you put R2?
Because right now outside I have 1. In my first term, I'm trying to get up to 3 of them. So if I have 1 right now, and I need to make it to 3, I need 2 more. Yeah, it's like I'm kind of mentally doing the distributive property before I get there.
Right.
And then when I get to here, 4 times 2 gets me to 8. And again, when I go into my adding battle here, r to the first, that's the same thing. I don't need an r. But if I have 1 t and I need to get to 2, how many more do I need? 1. And the nice thing about this is I can even double check and make sure I'm doing this right. For instance here, okay, 4 times 3 is 12. 1 plus 2 is r to the 3rd. And there's my t. So my first term's good. 4 times negative 2 is negative 8. I've got my r to the 1st. And t to the 1 plus 1 is 2. Nice way to double check, and I know I've got the right answer that way. So that's how that works. So then we get up to 9, and we might start bouncing around a little bit here in a minute. We'll see. Okay, 11 and 22, my chart would help me out on this one. It's going to be 11. Smallest exponent on A is A squared. What about D? Just D, because that's my smallest one. Smallest exponents, biggest numbers that go in. So let's see here. 11 times what's 11? 1. I have 2 A's. I need to get to 3, so how many more do I need? I need 1 more A. And I only need D to the 1st, and I already have that, so I'm good. I'm going to move this down a little and try to jumbo a little bit more here. I have a feeling my exponents may be a little hard to see otherwise. One more time just for fun. Now we're in good jumbo size. All right. So now that I'm up to here, and I say, okay, so my next one, 11 times what gets me to 22 is 2. Yep, and I've already got my 2 A's, so I don't need any more A's. But I only have 1 D and I need 2, so I need 1 more. And I'm good to go there. So again, on some of these, it's just the idea of taking my time and using my tools. All right, so 10, biggest number into 18 and 27. 9. And again, that's another one of those, you might start looking on your chart, you see 3 would work, but always look for that biggest one. So take a minute and look for the biggest one as well. Do I have any variables I get to pull out this time? No, because this one has A, this one has B, but neither of them have both. So here, 9 times 3 is 27. And since I have no variables out there at all, I need them all included here. And then I do the same thing with my next term. 9 times 2 is 18. And I have no variables out here, so I have to include it. So 9 times 3 is 27, a squared. 9 times 2 is 18, b squared. I'm done. Let's see here. How's about, let's take a look at 12, and then we may move to the back for a little bit here. So here, when I get to 12, I agree, 9's the biggest one. All right. I notice there's p's in all three. There's r's in all three, so I'm going to get to use both. My p's, I see a 1. That's as small as it gets. My r's, I see the smallest one is 2. And then we just go into building mode. Let me scooch over a little here. All right, so let's see. 9 times what gets me to 9? 1. I have 1p. I need to get to 2. So how many more do I need? 1. R, I have 2. I need to get to 2. I'm already good. I have all of my need. Put in my minus. 9 times what gets me to 27? 3. I've already got my 1p, so I'm good there. Now here I have 2 r's. I need to get to 3. I need 1 more of those.
R1.
Yep, R1. Because 2 and 1 get me to 3. And then finally, 9 times 2 is 18. I've already got my p to the first, so I don't need any more p's. But r, I have 2. I need to get to 4. I need 2 more. It's like doing individual problems within these. Every one is one we need to work on a little bit. So for the moment, I'm going to flip us over to the back. If we get done there and got some extra time, we'll come back, probably knock those out too. But if you haven't already, cross out 15 through 20 on the front of your review. Now, I'm going to give you a little bit of a preview here of something. Okay, 20, 21, and 22 will not be on your quiz tomorrow. It's going to be what's coming up on the next unit, but I like to give little previews on things when I can. So, what we're going to do is we're going to take a peek at this. And we're going to do something here in a moment that's called the diamond. Now, probably most of you have seen this before, and if you haven't, it's a pretty good concept here. What I'm trying to do with the diamond is, I'm looking for 2 numbers that multiply to get the number at the end, but add to get the number in the middle. You're like, wait a minute, what? Yeah. So, here's my deal. Normally I make this diamond thing, it just makes things more interesting. So I want them to add up to the number in front of my variable, and the same 2 numbers multiply to get here. Now again, if rattling off multiples, 2 numbers that multiply to 100 is not your thing, you have a couple of options. Okay. One of your options would be, you'll never guess, yes, the chart. I'm going to scroll back out a little bit here for just a minute. Oh, it's going on a mind of its own. Look out. Okay. If I'm not sure, here's another way I can use the chart when I'm doing this. So I can start looking through the chart, and I can say, okay, I need to find 100 somewhere in the chart. Okay, there's 100. So what does 100 multiply to get? Well, if I go this way, it's 10 and 10. So 10 times 10 is 100. Does 10 and 10 add up to 20? Yeah. So here's the one thing I have to watch out for, though. Does 10 and 10 add up to negative 20? No. So is negative 10 plus 10 negative 20? No. That'd be 0. It'd be like I owe somebody 10 bucks, I pay him 10 back. Is negative 10 plus negative 10 negative 20? Yeah. Because if I owe somebody $10, and I borrow 10 more. Now I owe him 20. What do you get when you do negative times negative? Positive. So here's how this works. Once I've done this diamond, I'm going to make 2 sets of parentheses. Whatever numbers I get in the sides are going to go at the end, and whatever my variable is in front goes at the start. Notice it's not b squared, it's just b. And then if I were to FOIL this back out or box this back out, I'd get back to the original problem. But this is an introduction to factored form, which we're actually going to get into tomorrow after the quiz. So I just wanted to get you a little bit of a heads up on that. We'll skip 21 for right now, because it's going to be a couple of days before we do the perfect squares. But let's do this last one and see if we can knock one of these out. So again, the goal is add to get the number in the middle and multiply to get the number on the end. So what are a couple of numbers that multiply to get 16? 4 and 4, okay? And it's not necessarily every time going to be the exact same number for both, like it happened to be on these two, but that's kind of the thought process we're working through. And it may be something where, even if you're not sure, you go to the chart and you're like, well, 16's in a bunch of places here. So 16 could be 8 times 2, it could be 4 times 4, but then you figure out which one by which one adds up. Okay? 8 plus 2 doesn't add up to 8. So once I get the 2 numbers on the sides, again, these are both positive 4s, so I'm going to put pluses with them. And then whatever letters at the start, this time it's A, I put A's in there. Okay? 21 would be a little bit different in that I can't do a diamond on that one because I have a number in front. So here's how these work. These are perfect squares. So let me introduce this with the chart a little bit here, just so you can see how it works. You'll get an intro. On your charts, when you're going through working with these, every time you get to a number, and actually it's this diagonal here, every number on the diagonal is what's called a perfect square. And perfect squares mean I multiply the same number by itself. So like 64 is 8 times 8. 49 is 7 times 7. 36 is 6 times 6. So all the numbers that go down throughout this entire diagonal, I'll bring this up so you can see them all the way down, are the numbers you'd use on a problem like this. Because if you look, it says 121 and 144. Well, okay, what do you times by itself to get 121 if you look in the chart? 11, because there's the 121, and it's 11 and 11. So what I would do for this one is I'd put 11 for the first, and I see the variable's m, so I'll put that along with. Then I go back to the chart, and I'm like, okay, 144 is my other number. Oh, there's my 144. It's 12 and 12. So I'm like, okay, so 12 and 12, P is with this one. But if I want to get a minus in the middle and I'm multiplying, can I put both of these as minus? No, because negative times negative is positive. So I need one to be positive and one to be negative. And it doesn't matter which one's which. And that's how that would be factored. So we are going to be using a lot of stuff with the chart, or just you'll probably get to know those perfect squares after a while, and you can just snap them off the top of your head. But that's how that one would work. So 20 through 22, again, just a preview of what's going to be coming up in our next sections after the quiz. This stuff will not be on the quiz. Okay? Now the stuff at the bottom, absolutely fair game. Okay. Spiral review. Boxing or foiling, again, whether you say, okay, I don't like the whole box thing, so I'm going to do first times first, 4 times negative 4 times x is negative 4x, 5 times x is 5x, There's our little smiley-faced guy. 5 times negative 4 is negative 20. But be careful, your signs matter. When I'm combining my like terms, what's negative 4 plus 5? Positive 1. Okay, I can't just say combine like terms and add them up and say it's 9. Okay, that doesn't work. I've got to watch out for my signs to make sure I'm doing this the right way. Now, if you like the box way better, okay, we'll do that on 24. If you like the visual organization that the box can do for you, then this is what we do. And it doesn't matter which side I put these on. If you put 2x minus 1 down the side and x plus 6 across the top, that's okay. And then we're just multiplying the terms to fill in the box. So 2x squared, because 1 plus 1 is 2. Negative 1x. 6 times 2 is a positive 12x. 6 times negative 1 is negative 6. Now, I still have got to write this out like I did in 23. I can't just leave it in the box. Right, and the nice thing here is my diagonal will always have my terms that are alike. 12, take away 1, again, we're not multiplying anymore, is 11x minus 6. And again, FOIL would work on those too. And actually, I do want to do 26 just because there's a little wrinkle that shows up here, and I want to make sure we get this right. So no matter which way you go again, box or FOIL. So if we go with foiling again, x times x would be x squared. And I have minus 8x and a plus 8x. And again, remember, we're multiplying to do the FOIL, so it's minus 64. Okay, I'm not adding them, it's not 0. Yeah, when I go to combine my like terms then, negative 8 and positive 8, if I owe somebody $8 and then I pay them 8 back, I don't owe them anything anymore. So my x's are gone. Minus 64. So you may even have your x term completely disappear. That can happen. But just be cautious, just be aware of that when you're doing your foiling. And then finally at the bottom, more equations review, because no matter what algebra class you're ever in, well, equations are just part of the deal. And I even gave you a little note here at the top. Distribute first if there's parentheses, then get all the x's to one side, then solve it. So I see parentheses, so I have to distribute first. Yep. And you're multiplying when you distribute, so that's step 1. Second job, all the x's to one side, but remember, that equal sign's like a brick wall. So I can't, all the x's to one side first, even though I could do that. I could do the plus 15, but the reason I'm always stressing getting all the x's to one side first is sometimes that confuses people if they're not. To me, I like to keep them positive. So, since this is a positive 3x, I'm going to minus it. Now, some of you may always want the x's on the left side. It's your own personal preference, but I really do want you to get all of your x's to one side first. And if you want to put the 1 in front of the x, you can. Now that all my x's are together, I got one step to get them alone, plus the 10. And there's several ways you can get to the right answer. I'm not saying there isn't, but I just like getting you one way that's going to be consistent and work every time, where you're not going to have some of the dilemmas you have if you go off on your own with this. Same deal going in 27. If you see the parentheses, that distributing has to be done first, and watch out for signs. Negative 2 times positive 4 is negative 8. And if I mess up the sign at the beginning, I'm kind of screwed. So I've got to be sure I get that done right. Again, my next job, get all the x's together. So somebody fire an idea at me, because there's a couple of options here. What's one way I could get all the x's together? Okay, I could add 2x. So wipe those guys out. And again, the equals sign's there for a reason. It's your wall. Don't start moving things to opposite sides of the equals. Yep. And so now I'm working on getting x alone, so I'll minus the 17. And my last step then is to divide by the number with x, which is 5. And x ends up being -5. So it can be quite a little process. I'm not saying it isn't. But if you take your time, kind of follow the little notes from above, it can help you out. All right, one last one. And then I'll have you work on the rest of them here just to kind of get you some extra practice. Ooh, double parentheses. All right. What's the left side of my equation going to look like once I distribute my 6? What's this going to look like? Okay, 6x minus 18. Okay, and then 5x and 5 times 8, distribute as multiply, is 40. Now again, I want to get all my x's together. So what's one way I could do that? I got to do an opposite to one of my, what's that? Okay, we could minus 6, that's an option. If some of you minus 5 going the other way, that would work too. Now my goal is to get that x term by itself. How do I get rid of this guy? Minus the 40. Now this time x isn't quite alone yet. Yeah, I'm multiplying it by -1, so I have to divide. Okay, always look to see what your operation is. Equals x. Okay. So you've only got a few problems left. The quiz itself, I don't think is going to be quite as long as this is. But once we get done tomorrow, we are going to start working some and getting some practice with like what we were doing up in 20 through 22. So the quiz won't take the whole period, and then we'll kind of jump into that, and we'll be heading down the home stretch of things.